Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And this video, another video in our series of videos dealing with SPSS procedures. And more importantly, this video is going to concentrate on a non-parametric test, okay? An alternative test to the independent samples t-test. I suppose there's some conditions or some preconditions associated with this particular test and also with the independent samples t-test. For example, this test that we're going to do, it's known as the Mann-Whitney test, okay? And what it allows us to do is it allows us to test to see whether there's any observed differences between two groups and more importantly two groups of data. So let me just maybe walk through the data set that I have here. I have two variables, okay? I have the independent variable, which is gender. There's two levels of measurement in this particular variable. Okay, there's males and there's females, okay, and then I have the dependent variable, which is exam grade. So what I have here is a list for each participant. We have their gender recorded and we also have their score in their latest maths exam, let's say for argument's sake. And I want to know whether there's a difference between the performance of the males compared to the females. Now what we could do is we could run an independent samples t-test to ascertain whether that difference actually exists. But one of the preconditions associated with an independent samples t-test is that the groups, okay, are two groups that the values of the dependent variable are relatively normally distributed. Okay, that's one condition. There's also other conditions associated with it in relation to, like, for example, variance, homogeneity of variances across the groups. Okay? But one of the main reasons is the normality assumption. Now, what I'm going to do first of all is I'm just going to plot the exam grade variable. We're just going to actually just explore it for a moment, yeah, to actually see whether these particular distributions are normal or not normal, yeah. And then what we'll do is we'll move on and we'll actually do the Mann-Whitney test, the test for differences. So I just want to test for normality. I've already generated this data here, okay, so I actually already know that it's actually have to be taken from a positively skewed distribution. So the male distribution was positively skewed and the female population distribution was positively skewed, and I randomly selected from that. But I already know that these are positively skewed and significantly positively skewed. But let's just test to see whether the normality assumption is met in this particular instance. So I'm just going to go to Analyze. I'm going to go to Descriptive Statistics and I'm going to choose Explore, okay? And then we get this pop-up window, the Explore pop-up window. Our dependent list or our dependent variable is going to be exam grade. And the way we're going to split exam grade into the groups is based on a factor, and the factor is going to be gender, okay? 1 represents males, 2 represents females. I'm just going to choose some plots here, okay? The plots I'm looking for are normality plots with tests. I'll probably choose histograms as well. I don't need stem and leaves. And I'll just hit Continue. Okay, so the output now is going to give us some normality results. Okay, so I'm just going to hit OK on that. And what we get after a moment or two, it's just doing a lot of processing, we get the output from the Explore function. Okay, so you can actually see here from a case summary perspective that the males, there was 996 males, there was 996 females. I generated samples that were equal sizes, yeah, okay, but they don't have to be equal sizes, but they have to be relatively equal, I suppose. That's important. And then we have the descriptive statistics here, okay, with respect to the two distributions. And what we see here is that the average, the mean exam grade for males was 53.99%, so about 54%, and the average exam score for females was about 67%. Now, an independent samples t-test will test to see whether there's differences between those two mean values. Are they significantly different to each other? Okay? But once again, the concept of normality and the precondition of normality needs to be satisfied. So, is the male distribution normal? Is the female distribution normal? Don't know just yet. Let's just actually check out here. We have our results for our tests of normality. We're going to rely on the Shapiro-Wilks test. The null hypothesis associated with this test is that the distribution is normal. The alternative is that the distribution is not normal. Once again, to reject the null, the rhyme that we've used up to this particular stage is if the p is low, the null must go. Okay, if the probability of observing the data, assuming the null is true, okay, if that's very low, we'll reject the null hypothesis. Actually, what we really want to see is if the significance value is less than 0.05. That's if we set a significance level of 5%. If the sig value is less than 0.05, we know we've deviated from normality. And you can actually see in both cases the male and the female distributions Okay? The sig values are less than 0.05 in both cases. So there's evidence to suggest that these two distributions are not normally distributed, in which case we wouldn't be able to rely upon the independent samples t-test, although it is quite robust. Okay? But in this case we've significant deviations from normality, and you'll see with the histograms. There's the histogram for the male. You can see it's positively skewed. Okay, there's the histogram for the female, and once again you can see that there's a significant positive skew with respect to that distribution. So just because we've deviated from normality, we can't rely upon the independent samples t-test. But there is another test that we can do. It's known as a non-parametric test, and it's called the Mann-Whitney test. So let's actually just run that test now. Okay, so I'm going to go to Analyze. I'm going to go down to Non-parametric tests. I'm going to choose legacy dialogues, and what I'm going to choose is two independent samples, okay? Because I have two groups, I have the males and I also have the females. So I'm going to choose two independent samples, and I'm just going to click on that, and here's our pop-up window. My test variable is going to be my dependent variable, so exam grade is going in there. My grouping variable is my gender variable, and that goes in here. And now gender just happens to just have two groups, so I'm just going to define them to be the groups 1 and the groups 2. Okay, that's the way we label them, 1 and 2, 1 meaning male, 2 meaning female. I'm just going to hit continue. And you can see by default what we get here is we get the Mann-Whitney U Test results. Okay, I'm just going to ask for something else as well here. I'm just going to go to options. I'm going to ask for descriptive statistics and quartiles, albeit these aren't really going to be useful for us here. We're going to actually have to generate them by looking at descriptive statistics through the analyze option. Yeah, but let's just hit this here so that we actually get the results. Okay, and what I'm going